Precision is the closeness of various measurements, and accuracy is the agreement of a particular value to the true value of the result. In other words, precision is described as how close the values are when many measurements are made. For example, these darts show a high precision, but what about accuracy? Even though the darts are very precise, they are not accurate. Accuracy represents how close the value is to the real value. These darts show high accuracy but low precision. But this dartboard shows both a high accuracy as well as a high precision. Significant figures are the reliable digits in a number of measurement that are known with certainty. A measurement with more significant figures is more accurate than a number with less significant figures. All non-zero digits are significant. For example, in 2345 there are 4 significant figures. And in the number 0.579 there are 3 significant figures. Zeros that are followed by non-zero digits are not significant. For example, in 0.058 there are 2 significant figures. The zero that lies between 2 non-zero digits are significant. That is, there are 3 significant figures in 0.203. Zeros that follow the number after the decimal point are significant. There are 3 significant figures in 0.600. Zeros after decimal point and before non-zero numbers are not significant. Thus, there are 2 significant figures in 0.0032. Zeros that follow the numbers without decimal point are not significant. There is only 1 significant figure in 600. Now, can you tell why zeros in 600 are insignificant? Well, this is because 600 can be represented as scientific notation as 6 into 10 raised to 2. Hence, the significant number is 1. However, if this number is given in scientific notation as 6.00 into 10 raised to 2, the significant figures are 3. Counting numbers of objects have infinite significant figures. As these are exact numbers, they can be written in infinite number of zeros after placing a decimal. In scientific notation, all digits are significant. Addition and subtraction are carried out as a normal procedure, but the presentation of results is different. The digits after decimal point in the result should not be greater than either of the original numbers. On adding the numbers 5.6 and 8.24, we get the result of 13.84. So, the result should be reported as 13.8 because 5.6 has 1 digit after the decimal point. When the number 14.687 is subtracted from 58.64, the result obtained is 43.953, which should be reported as 43.95 because 58.64 has 2 digits after the decimal point. In multiplication and division, the result should not have greater significant figures than the original numbers. When the numbers 4.58 and 2.1 are multiplied, the result obtained is 9.618. This result should be reported as 9.6 because 2.1 has only 2 significant figures. When the number 8.32 is divided by 1.2, 6.9333333 is obtained as the answer, which can be reported as 6.9 because 1.2 has only 2 significant figures. Rules to limit the number of significant figures in mathematical operation. If the rightmost number that is to be removed is greater than 5, then the preceding number is increased by 1, that is, 5.238 is reported as 5.24. If the rightmost digit that is to be removed is less than 5, then the preceding number is not changed. For example, 8.312 is reported as 8.31. If the dropping number is 5 and the preceding number is odd, then it is increased by 1. But if the preceding number is even, then it is not changed. For example, 5.375 is reported as 5.38 and 5.445 is reported as 5.44. Any calculation that involves the use of dimensions of the different physical quantities involved is called dimensional analysis. It is used to convert a physical quantity given in one type of unit into some other unit. It is also used to obtain the correct units when problems are being solved. For example, let us convert 125 pounds into kilograms. The unit of weight in pounds gets cancelled out from the numerator and the denominator, and we get the required answer in kilograms.